Hey everyone, welcome back. We're doing a little follow-up on the Agilent 54624A oscilloscope that I picked up about a month or two back. As I mentioned in the last video about this one, this is a bit of a Frankenstein scope. It's put together from parts from 3 different scopes, but I have it all together and it works pretty well. The one thing I did mention that was an issue with it was the battery was going and that I was going to have to replace that. So I went online, I ordered some batteries. This one is still wrapped up, but it's a coin cell battery, and part number I got after looking online looked like the right part number. And so I ordered it. And when I opened the battery up, I realized it's not the right battery. The tabs on the battery were not correct. So instead of just unsoldering the old battery and soldering a new one in, I had to get creative, let's say. So, see if I can prop this up here. So if you can see, let me try and zoom in a little bit here better on that. There we go. We'll take another look, but let me zoom in here. What I had to do is I had to cut the battery tab. I basically peeled the tabs off the top and bottom of the battery and solder the tabs for this battery onto it. Here, I'm just going to set this down and we're going to reposition that. Here we go. So it looks a little janky. It's on an angle, it's soldered in there, it certainly doesn't exude professional, but it's in there and it does work. There's no shorting of the leads, not touching anything else. I've plugged in the scope and done a calibration on it and kept the calibration fine, kept the real-time clock fine. So in that respect, it was a success. And as long as it doesn't fly around in there, which it's not, kind of don't care what it looks like. I'm not planning to ever have to replace this battery again, so that's fixed up. But what I thought we'd do is take a look at the scope that it's replacing. This is a 54645A, 2-channel, 100 megahertz, mega zoom scope. This is the one that I put the colorful knobs on. And it's a good scope, I like it. It's been working well, but I had a chance to get a 4-channel version, and so I did that. So let's take the cover off of this, and you can see what's inside of here and what will be sort of the next project. Oh, this module, this is the printing measurement module. So this is what lets it do FFT. But if you look, you can see same idea. Less ports on the back of this one. This just has the expansion port, and it has a calibration out. So to self-calibrate this, you have to hook a cable from the back. But let's take a look inside this one. It's much the same design. Real quick here, we'll just, power supply is on the left, video is on the right. And if we flip this over, I'm going to prop this up this way. Will it stay? It's not going to really stay. Let's do it this way. Okay, I'll just hold it. Because the piece that I want to take a look at is this thing right here. And let me zoom in. See if I can reposition a bit. It's right here. And it's this Dallas non-volatile RAM chip. This is what keeps the calibration settings in it. And this is a static RAM that is battery backed, but it's all enclosed in one package. And these are, there's no way to change the batteries or anything with them. I mean, some people have taken them out and drilled out certain areas on there to get and piggyback a battery onto it, but it's really kind of a messy thing to do. Let me see if I can if we can see here. You know, it's one big block there. So my next project is going to be, because I have 3 of these scopes. This is a 100 megahertz scope. I have a 60 megahertz version of this. And I have, let me just zoom back out, and I have an HP logic analyzer that looks exactly the same as this. They all use that same battery-backed RAM. And while none of them are complaining yet, it's only a matter of time. And so, you know, you buy old equipment, you got to maintain it. And what we'll be looking at for the next time, I'll screw that together in a minute. What we'll be looking at the next time is you can replace these non-volatile RAM things with what's called FRAM, ferromagnetic RAM, which is non-volatile but doesn't require a battery. However, those chips are surface mount chips. So I got a bunch of these little adapter boards here. And these boards will replace the Dallas DS1225Y non-volatile RAM. So we're going to solder some of these up. We're going to test them out, make sure that we can actually read and write from them the same as we would for that Dallas chip. And then we're going to pop one in one of the scopes here and see how it works. But for now we're just going to replace this model, which is, like I said, 2 channels, 100 megahertz. We're going to replace this one with the newer 4-channel one, which I have replaced the battery in, so that should be good to go for another good number of years. And we'll probably relegate this scope to my secondary bench in place of the 60 megahertz version that was sitting there. And there we go. And back together. So that's that one. And just to get a little bit of a, we're going to move out, get a little bit of a side-by-side view here. So you can see the new one is a little bit, tiny bit wider, but basically the exact same scope. All right, that's it. Just wanted to do a quick little update about replacing the battery, showing what the battery is like in the other scope, and that's it. All right, questions, comments, leave them below, like and subscribe if you want, and I'll see you in the next video. Take it easy.